Okay, so with this video, we're going to talk about how to draw sugar and salt and how it dissolves. And the reason why we're looking at these two compounds is because salt is an ionic compound, whereas sugar is going to be a covalent compound. So remember, that means that salt is going to undergo solvation and dissociation, okay? Meaning that the compounds are going to, the formula units, the particles of salt are going to separate from each other, but they are going to further separate into their ions, sodium and chlorine. Whereas sugar is going to be solvation only. So there's that. And I've taken the liberty of drawing before and after in each section and going ahead and drawing what my waters look like. So in this case, the water is, the oxygens are the red circles and the two hydrogens are the gray circles. And what we're going to do is when salt is added, salt has the formula units like this, and it's kind of like a crystal. And so these pieces are all really close together when they are when they're solid. And so if we're adding this salt into our water solution, what's going to happen is that our pink chloride ions, so we drew 1, 2, 3, 4, 5 of them. So these 5 are going to be separated from our green sodium ions. Okay, but the way the water orients itself is that the oxygen is always going to be what is near the positive sodium. So right now I'm just drawing my oxygens here because the oxygens are attracted to the positive sodiums, and the hydrogens are going to be pointed away, and that's because the hydrogens are positive charge and so are the sodiums, and opposites attract in terms of electrical charge. And so this is going to take, it's a little tedious to draw all of these circles, but it does help in terms of our look. But the chlorine ions are going to be different. When water surrounds those, your hydrogen atoms are going to be what is closest to it. So if I put my oxygens, you'll see that the hydrogens are going to be actually closest to it because those hydrogens are my positive charges. And so the oxygens will kind of be away from it. And so we can draw that for every single one of our chlorine ions. So I'm going to draw my hydrogens all near that, and we will be able to move on. So the fact that our ions separated makes it dissociation, and so in terms of the pink separating from the green, but the fact that one pink-green combo separated from another pink-green combo was solvation. And so this looks a little different than when sugar dissolves. And so when sugar dissolves, which let's just say the blue part of sugar is going to be our carbon, and hydrogen is orange, and oxygen is purple. What happens is if, let's say we have 3 sugar molecules, so we'll have 3 of these particles. Okay, so all together, this is a particle, this is a particle, and this is a particle. So here we have 3 particles being added, whereas before in our salt we had 5 particles being added because we had 5 combinations of our sodium chloride. So after these particles are added into our water, the unique thing, which makes it definitely a lot easier to draw, is that when you have your sugar, each of our 3 sugar particles are going to be separate from each other, which I guess I should have drawn these a little closer together. These particles here are actually in a solid going to be almost on top of each other. So let's move those a little closer. There we go. And if we erase these boxes, you'll see that they're much closer together. But when they dissolve in water, they're going to separate. Now, because sugar is covalent, they are not going to have partial or negative charges. So that means when sugar dissolves, you're going to have water surround all of the particles, but it's not going to matter whether or not oxygen or hydrogen is closest. So I went ahead and drew my oxygens around them, but you'll notice when I put the hydrogens, sometimes I'm drawing the hydrogens close by, sometimes I'm drawing them on the other side. It doesn't really matter how the water is oriented around it. They could all be pointing towards or away or apart from it, but the main thing is that the water is surrounding the particles and keeping them separated, and so that is solvation. So again, salt, which is ionic, undergoes solvation and dissociation, but sugar only undergoes solvation. And so hopefully that is a good review. If you don't know what I'm talking about in terms of solvation and dissociation, check out the previous video when we kind of walked through some vocabulary. And this diagram is kind of a labeled version of what we just drew here. But of course, my pictures are not always as good as maybe a professional drawing. So anyway, I hope that helps, and stay tuned for the next video.